Okay, Assalamualaikum and good afternoon to all my students, MEC281 Group H. So for today, we are going to learn about the crystallographic points, directions and planes. Okay, so this is the subchapter of 1.3. Okay, we start with the Miller Indices. This is all about the direction and the coordinate of the crystal in the material itself. Why the Miller indices is important? Okay, because of to determine the shapes of single crystal, the interpretation of X-ray diffraction patterns, and the movement of dislocation. When you study about the material itself, we have to know the location, the dislocation of the material itself, which may determine the mechanical properties of the material. So the final outcome that we want to know about a certain studies of the material is all about the mechanical properties. Okay, so for today we are going to learn about how to determine the directions and the planes, okay, by using the Miller indices system right here. Okay, so it looks complicated at first, but don't worry. When we get along, this is quite simple and easy. Okay, so the focus of our topic is this one, crystal plane of phase, by putting the parentheses in front of the x, y, and z. Okay, axis. So in the Miller indices, they do not put the x, y, and z. They replace it with the symbol of h, k, and l. Okay, so this is the plane that we are going to learn, and also this one, a specific crystal directions. Okay, so the difference between here is the parenthesis of the crystal plane, and this one is the enclosure symbol for the direction. So when we are going to write down the plane, we are going to use the parenthesis here, and if we write the directions, okay, we have to put the enclosure symbol here. Okay, so let's go to the next slides. Okay, first you have to recall back what you have learned in your mathematics or physics during your SPM, the point coordinates. Okay, so let's get revised. The point number here 1 to 9 is over here. Okay, so let's write down the x, y, and axis and the point coordinates. So this is the point coordinates in the y, x, y, and z, the Cartesian coordinates. But it is no yet of the Miller indices. So by using the coordinates here, we will convert x, y, z into the Miller indices. Okay, so point number 1 here, right here. Okay, so this is the origin of the axis itself. So this is the 0, 0, 0. At the x-axis, it is at origin, so it is 0. At y-axis, here, it also at origin, so it is 0. And z-axis, it's also at origin. So you put here 0, 0, 0. So the point coordinate of point 1 here is 0, 0, 0, right? So this is the point coordinated. Okay, so the point 2 here. Okay, so A, this one A, so this one A. So we have to assume A is 1. A here is 1. This one 1. So point number 2, at the x-axis, it at point 1 or A. Yeah. or A. I put also 1 times A also A. Okay, so y-axis, point to y-axis, okay, it is 0. Z-axis, at the point 2 here, it is 0. So you can write down A 0 0, or maybe if you know A is 1, so you can put 1 0 0. Okay, and so on. So I do not want to complete all the tables here, so you have to do by your own. Okay, let's try another example at the point number of 9. Okay, so 9 in at here, it is x-axis, it is on the origin. So 9 is 0 of x-axis. For the y-axis, it is A. Okay, z-axis, it is also A. So you can write down 0 A or 0 1 1. Okay, so that's basically the point coordinates of the 3D dimensions. Okay, so let's go to the Miller indices of a direction. So this is the important thing. Okay, from the coordinate there, you have to convert into the Miller indices. So for our chapter, we are going to learn about the directions and the planes. So in this slide, this is all about the directions. Okay, let's read first how to determine crystal direction indices. Okay, the first one is you have to determine the length of the vector projection on each of the 3 axes based on x2, y2, z2 minus x1, y1, z1. Okay, and then these 3 numbers are expressed as the smallest integer, and negative quantities are indicated with an over bar. Okay, so if you have negative point, let's say this is one is negative 1, you do not put the negative symbol here. You have to put the crossbar at the above of number 1. So we know that 1 here is negative in value because it has crossbar over the number 1 here. Okay, and then you have to label the directions in the enclosure here, symbol H, K, L. So basically this is the table procedures that you have to do for every problems of directions. Okay, first head is the final error, tail is the first initial point, and you have to minus head minus tail. So outcome minus input, output minus input, and then you will get the value here. And you have to do the reduction. Reduction is you have to convert the smallest, if it is in the fraction number, you have to multiply to get the smallest integer, because we do not want the point or fractions number in the enclosure here. The final value must be in the integer. So let's say is 2 1.5, you have to multiply with 2, so 1.5 will become 1. So the other number also have to multiply with 2. Okay, so that's how you convert into the smallest integer. Okay, so let's try this example, crystal direction indices. Okay, so the first one, you also must create a table here. If you do not want to put the beautiful pretty table, just write down head, tail, reduction, and enclosure, because it maybe can help you to get the final value easily. Okay, so head here is 110. Okay, so I copy first. Okay, so this we try this example first. Okay, head here 110, so you put 110. So the tail number here is from the origin, so origin is the 000. So the reduction head 1 minus 0, so is 1. 1 minus 0 is 1, and the 0 minus 0 is 0. So the enclosure is 110. So that is the final value, 110. Okay, so that is the directions of this example. So this is the answer. Okay, let's try the second one here. Head here is 1 0 0. The tail here is 0 1 0. So reduction is the head minus tail. So 1 minus 0 is 1, 0 minus 1 is minus 1, 0 minus 0 is 0. So in the enclosure here, will become 1, and the minus 1, it is not the minus sign here. You must put the crossbar. Okay, and then this is 0. So the final enclosure is 1 bar, and 0. Okay, so that is the final answer for the Miller indices of this direction. Okay, so let's try another exercise. Okay, so head here for the x is 0, and y is 1, but for the z it only 1/3 of the z-axis, so you have to put 1/3. That is the head. So the tail is all coming from the origin, so 0 0 0. So the reduction process is minus head minus tail. 0 minus 0 is 0, 1 minus 0 is 1, 1/3 minus 0 is 1/3. Okay, so as I mentioned earlier, you cannot put the fractions number, so you must convert into the smallest integer. How to get the smallest integer? So you have to multiply with 3, then 1/3 become 1. But 1 also must multiply with 3. 0 minus 0 multiply with 3 is 0. So 0, 1 multiply with 3 is 3. 1/3 times 3 is 1. So the final enclosure is 0 3 1. Okay, simple as that. Senang kan? Okay, and then let's try the other one here. You must try by your own, I hope, because if you do not do the exercise, I don't think you can understand this Miller indices. It is easy, but likewise of the mathematics problems, you have to do by your own. You have to try by your own. You have to do the exercises. Okay, so let's try another example here. The head here is at the x-axis is 1, and the y-axis is on the 0, and the z-axis is on 1. Okay, the tail on the x-axis it is on the 0, the y-axis it is 1, and the z is 0. So 1 minus 0 1 minus 1 1. So it is all in the integer number, so you do not have to multiply with certain number to get the smallest integer, because it is already in the smallest integer numbers. Okay, so enclosure is 1, this one is 1 crossbar, and this one is 1. So the final one is 1 crossbar and 1. Okay, let's try another one. Head here, x is on the 0, y, okay, half, y is on the half of y. Okay, so it is half. Z, okay, it is 3/4, third quarter. So the tail, x still 0, y is 0, and z is 3/4. Okay, so the reaction is 0, half, 0. So you have to multiply with 2 to get the smallest number. So 0 times 2 is 0, half times 2 is 1, and this one is 0. So the final enclosure is 0, 1, 0. Okay. Let's try the last one here. Hey, head here is 3/4 of x. Okay, 3/4. Y is 0. Z is 0. The tail, okay, from the x is 0. And y is on the 1. And the z is half. So head minus tail is 3/4. This is 1 is 1. This is minus half. So you have to convert to the smallest integer. If you times 2, you still do not get 3/4 here to get the integer number. So you have to times with 4, right? So times 4. So 3 times 4 is 3. 1 minus 1 times 4 is minus 4. This is minus 2. Okay, all agree? Okay, so for the enclosure, it will become 3 minus, we put the bar over cross bar, minus 2 cross bar. Okay, so that's the answer for this example. Okay, so this one you have to try by your own. Okay, I try to give another example. Determine the direction indices of the cubic direction between the position coordinates tail 3/4, 0, 1/4, and head 1, blah blah blah. Okay, so first of all, you have to do your wait a second. Okay. Oh, sorry. Okay. So this is Z, Y, and X. Okay. So this is 1, this is 1, this is 1. So you have to do the parallel to the x-axis. to get the cube or I just want the straight line. Okay. We do not have option. Just use the yellow one. Blue one. Okay. Never mind. So I will just use my hand. Minta maaf kalau tak straight. Cuba buat cube. Okay. Let's say this is the cube. So we have to put the value of I use the one red. Okay, red color. So this is half. This is half at the y-axis, and on the x-axis this is half. Okay, so if this is half, so this one is third quarter, this is the first quarter, right? So you have to approximate by your own, or estimate the points where is the 1 quarter or third quarter. So this is 1 quarter, so this is third quarter. Okay, so now let's put the point of use the one of green. Okay, the head first at the x-axis is 1 quarter, so it on this one, and then on the y-axis is on half. Okay, so this one here, half on the y-axis, and finally on the x-axis is half also, so stay on the point here. So approximate approximately the point is around here, so where it is located on 1 quarter of x-axis, half of the y-axis, and half of the z-axis. So this is the point of head. Okay, and now find the direct opposite points of the tail. So on the x-axis is on here, but for the y, okay, y is on the 0, and the z-axis is 1/3. So basically it is on here point. X is 3 quarter, y 0 on the origin axis, and z is 1/4. So the direction here will become, yeah, okay. Okay, so determine the direction indices of the cubic direction between the position coordinates. Okay, so this is the drawing of the cube itself, but the answers that these questions wants is not about this drawing. It wants the indices, the Miller indices. So if you do not draw first pun, is okay. Just use the steps here that we have done in the previous example. Okay, so just write down this one is 1/4, half and half, till 3/4, y 0, first quarter, 1/4, okay, a quarter, z. So you have to minus 1.4, 1/4 minus 3/4 is minus 2/4, or 1.5. Okay, 1/2 minus 0 is half. This is 1/4. Okay, so if you multiply with the 4 to get the smallest integer, so this one you will get minus 2, this one you will get 2, this one you will get 1. So the final enclosure is 2 crossbar, 2 and 1. Okay, so you do not have to draw the 3D dimensions here. I draw because I want you to imagine the position of the points here. But for these questions, it just want the direction indices. So the marks, if it is on the quiz or the test, the marks will be on the final indices here. So this one is wasteful effort lah. Okay, the draw itself is the wasteful effort in these questions. Okay, so that's all I think for the direction, Miller indices direction. So you have, this one is to draw, so you have to draw like this. Okay, so don't forget to do the tutorial 3, the question 4, 5 and 6 is all about the Miller indices, and then we will discuss it, or you can ask me the answer of the tutorial 3 in the WhatsApp group, or in this coming next class on this Friday. Okay, so make sure you do the Miller indices tutorial in the tutorial 3. Okay, so for now we get a break first. Let's have a 5 minutes break, and after that we continue with second Miller indices. That is the Miller indices plane. Okay, here. So let's get a break for 5 minutes. Okay, Assalamualaikum. So as I promised, after 5 minutes break, now we are going to learn about the Miller indices of a plane. Okay, so let's get started. How to determine crystal plane indices. Determine the point at which a given crystal plane intersect the three axes. So this is the key point here. You have to know where the point, where the plane itself intersect the three axes. Say at certain number of axes, here represented by the symbol of A, and then 0, 0, or 0, B0 and 0, 0, C. at the z-axis. If the plane is parallel and axis, it is given an intersection infinite. Okay, infinity symbol here. The plane is parallel. If the plane, I repeat again, if the plane is parallel and axis, so it does not intersect the axis. It is on the parallel. It never intersect the axis, so it is given an intersection infinity symbol. So it is infinite number. So imaginary number, large, very large number. So let's put the symbol of the infinity here. Okay. Take the reciprocals of the three integer found in step 1. Reciprocals is you have to invert the number. So let's say a, so when you do the reciprocals, so 1 over a, so 1 over 0 is still 0. 1 over 0 is infinite, 1 over 0 is finite. So for the b, 1 over b, c, 1 over c, same. Okay, so then label the plane HKL. Okay, what is the difference between the symbol here and the directions here? So in the directions, we have the bracket here, but for the plane, we have the parenthesis, the curved one. Okay, so means that if you put in the parenthesis here, so it is the plane. If you pull the bracket here, it is the direction. Okay, these three numbers are expressed as the smallest integer, and negative quantities are indicated with an over bar. Okay, so let's try look at some of the planes. Okay, so this one is 0, 0, 1. Okay, why on the x-axis is 0? Because on the x-axis it never intercept. It is on the parallel, so it is infinite. When you do reciprocals, 1 over finite. Okay, let's say we try first. So on the x-axis, infinite. Where is it? Okay, on the x-axis, it never intercept x-axis, so it is infinite. Okay, and then on the y-axis, it also never intercept the y-axis, so it is infinite. But for the z-axis, it is set on number 1, the value of 1. So when you do the reciprocals, you have to invert 1 over infinity, and then 1 over infinity, and then 1 over 1. So you intervert. Okay, reciprocals, you intervert that number, and then 1 over infinity is 0. You know that? That is what you have learned in the calculus. Okay, 1 over infinity is 0, so 1 over 1 is 1. So the final parenthesis, Miller indices of this plane is, you have to put the parenthesis 0, 0, 1. So that is our number. Okay, and for the 1, 0, 0 here, it is intercept x-axis at number 1. Okay, intercept. And for the y-axis, it never intercepts, so it is infinity. And also for the z-axis, it never intercepts, so it is infinity. So when you put the reciprocals, you have to invert that number. So 1 over 1, 1 over infinity, and then 1 over infinity. So you will get 1, 0, 0. So the enclosed one is 1, 0, 0. So that is our number. Okay, so let's try a complicated one here. Okay, so this one is intercept x axis. Yeah, it never intercept x axis, so it is infinity. And for the y, it is at number 1 here. Okay, and for the z axis, it intercept on the 1. Okay, so that's why you have to do reciprocals, 1 over infinity and 1 over 1, 1 over 1. So this is 0, this 1, this is 1. So the final one is 0, 1, 1. Okay, is it correct? Yes. Okay, let's try this one. Because we have the crossbar here, so it means the negative. Okay, so where it intercept at x, set at 1. Okay, for the y, okay, y axis okay, looks like this. Okay, y here, for me it looks never intercept. Okay, never mind, let's try another example. Okay, we read here first. If the plane passes through the selected origin, either another parallel plane must be constructed within the unit cell by an appropriate translation, or new origin must be established at the corner of another unit cell. At this point, the crystallographic plane either intersect or parallel each of the three axes. The length of the Penang intercept, blah blah blah. The reciprocals of this number are taken. A plane that parallels an axis must be considered to have a infinite intercept and therefore a zero index. If necessary, these three numbers are changed to the set of the smallest integer by the multiplication or division by a common factor. Okay, this one is the common type. Common statements are similar to the Miller direction before that we have learned before. Okay, finally, the integer indices not separated by commas are enclosed within parentheses. Thus, SQL. Okay, this one we already know. Okay, an intercept on the negative side of the origin is indicated by a bar. Okay, intercept on the negative side of the origin is indicated by a bar or minus sign position over the appropriate index. Furthermore, reversing the direction of all indices specified another plane parallel to on the opposite side of and equal distance from the origin. Several low index plane are represented in figure 1.3. Okay, we do not have that figure of 3.1. Okay, so it says that if it is on the opposite direction of x, so it is on the negative axis here, the bar. Okay, and for the y here is negative because it's the opposite direction of the normal y, positive y axis here, and also similar to that z. Okay, let's try this exercise first. I create similar table to the Miller indices of for direction. So just the different one is the intercept here, where it intercept the x and y and z axis. Okay, so let's try this example. For the x, it intercept at the 1/2. For the y, 1, and z, half. So when you do reciprocal, you turn it back, so 2/1, 1/1, so 2/1. Why? Because 1/1/2 will be 2/1, right? Okay, so you will get 2, 1, and 2. So the enclosure is 2, 1, 2. So we write down like this. Okay. Okay, so this question is on the tutorial 3. You have to try, but I give you 30 minutes to do all the exercise, and if you have the problems to solve it, you must try to Google it first or find in the textbooks first, and then still if you have the problems, you ask me in the WhatsApp group. So I think that's all for the essential information you have to know about the crystallographics of the direction and planes. So I think that's all for this video. You must try, you must do. I will not give all the answers. You must do by your own. So you are learning by doing the practices. Okay, so I think that's all for today. So in the next class, we are going to learn the final topics of the chapter 1, and then that's all for the chapter 1. So the quiz 1, schedule on, I think, a week after the Hari Raya, and then the quiz 1, the question of the quiz 1 covering the chapter 1. Okay, so almost of the chapter 1s are covered right now. Only the 1.4 mechanical properties of material is remaining, is this chapter 1. Okay, so assalamualaikum, and please do all this exercise. If you have the problem, like I said, Google it or find in the book first, and then if you still have the problems, ask me in the WhatsApp group. We discuss together. I do not want you to personal message me. Anything regarding to the academics questions, you must put in the WhatsApp group, so every students have to know the question itself, and every students can discuss with us together. Okay, once again, do the exercises. Okay, assalamualaikum, selamat berpuasa.